Welcome to Hawaii Invasive Species Awareness Month's webinar. This afternoon, we are going to be with JB Friday. He's an extension forester with the College of Tropical Agriculture and Human Resilience and is based in Hilo. JB's been working on the rapid ʻŌhiʻa death project since the first detection of rod in 2014, and today he's going to be discussing the efforts to protect what remains of our ʻŌhiʻa forest. Specifically really diving into how fencing and excluding destructive ungulates, and then also talking about the ongoing research and efforts to develop a disease-resistant ʻŌhiʻa to help preserve this culturally and ecologically vital native tree.
All right, welcome everyone. I'm still seeing the poll. Are we good? There we are. Yeah, what's at risk and what can we do with that? As Aaron said, I'm the extension forester of the University of Hawaii, CTAHR, and based in Hilo, and I've been based in Hilo for 27 years now. In this presentation, when I talk about we are doing something, it doesn't mean I'm directing a big group of people. We're a large group of people with different agencies working together. University of Hawaii, both at Manoa and Hilo, a lot of support from U.S. Forest Service, USDA Ag Research Service, and certainly the land management partners in here, the Division of Forestry and Wildlife and the national parks in particular, and then all the invasive species committees have been part of this. So I'm going to assume that everybody at the webinar here is familiar with ROD, but just in case someone isn't, just a couple basics of it. It is a new disease killing ʻŌhiʻa. We speculate sometime around 2005 was probably when the first tree went down. The first stand I saw that later we diagnosed ROD in was 2010, and as Aaron said, it was diagnosed in 2014. Two species of fungi, Ceratocystis leucoʻhiʻa and Ceratocystis hulioʻhiʻa. Now, the genus Ceratocystis is worldwide known pathogens, but it turns out we have two new species here in Hilo that were otherwise or previously unknown to science. But these are vascular wilt pathogens. They infect the sapwood. It cause the tree to stop being able to conduct moisture, and then all the leaves turn brown. And this is the typical characteristic you see here. All the leaves are brown, and the tree first turns brown and then dies. Our estimates, based on the remote sensing and field plots, are between 1 and 2 million ʻŌhiʻa trees have died, almost all in Hawaii Island, since this disease took hold. This is a picture of what a forest looks like 12 years after it first gets infected by ROD. This was a healthy ʻŌhiʻa forest. If you know the Big Island, it's at the height of land as you go from Pahoa up and then down to Kalapana and that area. And after 12 years of infection, the ʻŌhiʻa are dead. The fine branches have fallen off, and all is left in this area is a bunch of poles. Whatever was native in the understory has probably been swallowed up by all the weeds that have come in. So this is what's at risk, is things turning into something like this. On Hawaii Island, I mapped where we started seeing ROD until it got to the point where we do see ROD in all districts of the island. So you see in that map, the initial locations were in Lower Puna, and it's spread across the island. Until now, we do see some ROD in every district on the island. The change we're seeing, though, is initially you see all those yellow and light yellow dots down in Lower Puna. We don't see so much mortality there just because you do see those dead trees, the ones that have died. The forests, for whatever reason that were vulnerable, have died off, and we've lost a lot of that ʻŌhiʻa forest. What we're seeing now, though, is some more mortality up at higher elevations. So it's a little more out of the public eye, so people are not seeing so much ROD anymore. But to those of us in conservation, we're very concerned about it. This is on Mauna Kea at about over 5,000 foot elevation. And as you look across a pasture, you see an ʻŌhiʻa forest there, and almost all of those ʻŌhiʻa trees are dead. There's a lot of feral cattle in that area damaging the trees, and so we really see that significant mortality. On the island of Kauai, we also have both pathogens, leuco and huli, and it's spread across the island, but for reasons that we're not going to get into today, we're not really sure about, the disease is behaving differently in Kauai, and we're not seeing this landscape scale mortality that we did on Hawaii Island. And then on Oahu, it only has the less virulent pathogen, Ceratocystis hulioʻhiʻa. We suspect that hulioʻhiʻa has been here for decades, if not centuries, And it's not causing a level of mortality we'd have ever noticed. I mean, what is it, 13 dead trees on the entire island of Oahu. We never would have noticed anything wrong with that. And then Maui, Lanai, Molokai, there are no known trees infected with either of the pathogens. So our model of how the disease moves around involves insects. The infected trees are very attractive to various species of ambrosia beetles. The beetles burrow into the trees and then they create a lot of sawdust as they burrow in, or frass. And then that frass is full of the fungal spores. Because again, the fungus is in the sapwood. It's not like a rust pathogen, like the coffee leaf rust, that is a disease on the leaves. And then the spores just blow off the leaves and blow around, and it spreads very rapidly. The fungus is inside the wood, but if you're a beetle and you drill a hole in the wood, then you release sawdust that is full of fungal spores. And we know from experiments in the greenhouse, if you take that fungal spore laid in sawdust and you put it on an injury on a seedling, then you're going to get an infected seedlings. So in the forest, where you have a forest such as this here, this is the same place that I showed you in that landscape there earlier. There are a lot of feral cattle stripping the trees. If you're in a forest where like that, and there's this spore-laden frass blowing around and it lands on a fresh wound, it can infect the tree. So the big breakthrough, I think, in managing this disease, and I want to emphasize that forest disease that's widespread like this, it's about management. It's not a cure, it's not a solve. We're not greenhouse growers who can just throw out all the infected plants and buy fresh stock and solve a problem that way. It's there, it's a long-term thing that we will always be managing. But a key thing that we have found that is areas that have fences and are excluding the animals have much less disease. Now, this map here, the blue rectangle is the area of the helicopter flight. So this was a helicopter flight. And the red dotted line down the middle is a fence. And on the right side of the fence is state forest, and they have high population of pigs in the state forest there. On the left side, it's the national park. This is down in Kahuku on Hawaii Island, in Ka'u in Hawaii Island. And the national park has a policy of not having any pigs. The state forest is open for hunting, and so there are a lot of pigs in there. The red and white dots are trees that show rod symptoms from the air. And there's been a subsample of those done, and the positives are maybe 80% positive that they are rod trees. But you still see a preponderance of the trees that have rod are on the open side of the fence, not on the inside of the fence. And we see this pattern where basically the same forest, but because of a property difference, there's a fence and half is protected and half isn't. We see this property across the island. We see instances of this in Volcano. We see them in Ka'u here. We see them in some of the TNC properties. We've seen it up as far as Lapohoihoi and Kohala and other rod-infected forests. The folks working on this put together a story map where you can look at maps of these different areas and look at the imagery, look at some pictures of the area. There's the QR code for it. If you want to scan the QR code on your phone, it'll take you to that story and you can look through what this looks like at various sites across the island. I want to say this was a project that was carried out collaboratively. Ryan Proy, Tima Sullivan, Naya are at the UH Hilo remote sensing lab. So they were taking the remote sensing data first from drones and then from images from helicopters. And then Flint Hughes folks were on the ground doing the sampling, the on-the-ground sampling to see if this really was rod killing these trees. And Lisa Keith and her folks at the USDA Ag Research Service were doing the diagnostics. And then folks from Hawaii Volcanoes National Park were, first ones finding these things going on the ground and bringing them to our attention and then facilitating these studies. So it really was a lot of teamwork coming up with this study. But it really, this pattern is something we can do. And we've always had reason to protect forests from feral animals, but this is a really strong evidence. This is one way we can protect our forests. Mostly the animals that are implicated in this, most of them are cattle and pigs. Cattle bark trees, we know that. There's a picture of cattle on Mauna Kea wandering around a forest where they shouldn't be. Those are feral. There's nobody's cattle. They bark in trees. Feral pigs dig up roots. They rub against trees and they also dig up roots. Now, we know for some recent greenhouse studies that have been done that the tree roots don't seem to take up the pathogen until they're injured. So imagine a pig digging around the forest, tearing up a bunch of roots. Every torn root can be an ingress point for the disease. That's obviously there. That's a game cam. Flint Hughes and Kayla O'Kinney are working with Stara Knox to actually look at pig behavior, see what is actually going on the ground. What are the mechanisms of these patterns that we're seeing? And they're doing a lot of game cam work and finding out pigs and where they are and what their habits are and what they actually do in the forest that would cause the spread of the disease. They're also looking at how much are pigs physically spreading spores by getting mud with spores on it on their snout and running around the forest, and how much it's the damaging the plants. But fences, as anybody who's worked on Hawaii know, bring up a lot of issues. And are you excluding people from the forest when you build fences? Certainly, that's a widespread sense in the community that you're excluding people. If you're building a fence to keep pigs out, you are eliminating hunting from that area, whether or not people can get in the forest. And hunting is important. It's an important source of food for a lot of the rural communities. It's important recreation, and it's a long-standing tradition. The lower picture of the guy with the pig there was it was actually a pig hunting derby that we worked with folks in Nanavale, and they put on a pig hunting derby and invited us and a number of other outreach organizations, and we had a nice day, valuing the forest both for the game that it provides, and we had the chance to educate people about rapid ʻŌhiʻa death, native species, invasive species, and a lot of other things were there. And there are things you can do. I mean, you can there are things you can do, like put up stiles to let people access it. We're not trying to keep out lay gatherers and other people from the forest. On a landscape scale, there are trade-offs, and you really can't do everything on every acre. I really like these maps, and these are two very separate projects, but the one on the left shows aquifer recharge, and the one on the right shows pig activity for Oahu. The aquifer recharge is USGS, and they did it based on a model of rainfall and slope and soil type and all those things. And it shows you for the watershed, for what we really want about is the watershed being recharged, almost of it all is up in the Ko'olaus. Then the one on the right is Melissa Price with CTAHR in the Wildlife Lab with game cameras looked at feral animal activity and shows that the pig activity was in the foothills of the Ko'olaus, but not up on the summits. So on a landscape management area, maybe you could have some of the area protected for your watershed recharge, for your rare plants, and others areas open for hunting. With this in mind, we wanted to promote discussion among different forest users groups. So we developed a new video on protecting Hawaii's native forests. You can see it, you can link to it from our website, rapidohiadet.org. Also, it's on the Saving ʻŌhiʻa channel. Many of you remember the Saving ʻŌhiʻa video of about 6 years ago. We were able to use that channel. We posted this video to that channel. So if you go to YouTube and look up the Saving ʻŌhiʻa channel, it's on that. In this video, we interviewed different forest users, fish managers, hunters, conservationists, cultural practitioners about what they value about the forest and about protecting, about what they see in forests that are protected. So different people with different points of view. The bottom line of it all was that, and Justin Lee, the hunter pictured in the top left, said, look, we're all in Team Hawaii. We all love our forests. And whether you're a cultural practitioner, a hunter, or a wildlife biologist, we all want to protect our forests. We all love seeing our ʻŌhiʻa forests. And that's really the message that we wanted to get across is we're all trying to protect the forest here. And how can we do that? How can we work together to do that? Some other details and some other new things that are coming out. And again, I'm assuming people have been listening to Rod stuff over the years. Protecting ʻŌhiʻa trees from pruning. One of the common questions that I get frequently from landowners is, well, what about pruning a tree? What if I have to prune a tree? We have been recommending a wound sealer. And again, that's based on the model that the disease is spread by windblown frass blowing around, landing on wounds. So this is a tree in our courtyard that a branch broke and I had to prune it, and I applied our spectricide because that was the wound sealer we had. It's convenient. It's in a can. Those of you who know arboriculture know that wound sealers have been mostly discredited. But in this case, we thought it would be a worthwhile thing because we have wind-blown spores of a pathogen. But oil-based wound sealers aren't very great for trees. And Mark Hughes of the Forest Service did a study of different wound sealers. And he found that while the spectracide pruning seal helped, just plain latex paint was better. And outdoor latex-based paint was better because latex is less toxic to a tree. But there's another product that's a latex paint with boric acid, and the boric acid acts as a fungicide. You know, it's not a pesticide, it's not registered as a fungicide, but it was the best thing of all for protecting your trees from wounding, from infection, if you have to prune them or if they're wounded somehow. Unfortunately, that is not available commercially in Hawaii yet. It's just really a question of getting someone to import it and supply it. And DLNR is working on doing some orders, maybe to get it out to the ISCs, but then trying to persuade some of the agricultural supply houses to supply it so people can use it. So there's another tool that is we're about ready to have here. Another tool is insect repellent. Now, I saw this happening years ago when I was in the Rockies and they had these bark beetle outbreaks, and they were using repellents to protect their trees in campsites and parks. It wasn't something they could do over 1,000 acres, but you could go into a park and protect, a dozen trees around the campsites from the bark beetles. Um, the insect repellent is this goopy black stuff you see on the tree there. It's called splat because it just makes a splat when you apply it with a paint gun. But it's an insect repellent in a paste that sits on the tree and repels insects from the bark beetles in particular, or the ambrosia beetles from attacking the tree. That's Kyle Roy, who's now with the U.S. Forest Service. He studied that along with Dan Mikros at Hilo, and they did find that the beetle attack went way down if they applied that to trees. The utility of that is if you get one rod infected tree in an otherwise healthy forest, and if you could keep the beetles from hitting it until it died and dried down, then maybe it wouldn't spread in it. So that's a tool for a different situation when the disease is just incipient, your first tree to protect a tree. You could also use it to protect specific trees, but does seem to be a tool that would help it reduce the spread. It is something that it is a pesticide, so the registration and the regulations are still ongoing. It takes a while, but Kyle is hopeful we will be able to have that available soon. So on to the disease management study. The disease resistance program has been inoculating hundreds of seedlings with the pathogen. And the good news is that a lot of them, even though they've been inoculated with the pathogen, don't die. The process is because, again, it needs a wound to be infected the tree, they take a knife and take a little slice of bark off each seedling or each rooted cutting, and they put some of the pathogen in and wrap it up with tape. So this is the greenhouse out behind our lab here, our offices here. And you see that one on the left there just went down. So they inoculate it. That is about 3 months after they inoculated it. And one by one, the trees are going down, but some of them aren't. So they're showing good indication that there is natural resistance to the disease in the populations, our native populations. This work again is combined work with people from the Forest Service at Christian Giardina and Mark Hughes leading it up with advice from Rich Snesko on the mainland, and then Eileen Ye, and then Ryan Belcher and I know go from the Akaka Foundation are the ones actually managing and carrying out the experiments. So to me, at least, the results are very encouraging. So this is just a number of different clones and the disease severity score. So 5, they all died, and no bar all the way to 4-8. None of them got the disease. So most ʻŌhiʻa are vulnerable, as is not surprising. We see it going through the forest like that, but most are not vulnerable, but are vulnerable. But a few of them seem to be resistant. So a number of the ones with green bars, only 1 out of the 5 sample trial ones from that family got the disease, and the ones on the far right, none of them got disease, even though they were inoculated with the pathogen. So that's a hopeful first step. So what you need to do now is plant it out in the field, see how things do in the field, and then the vision down the road is developing seed orchards. So the vision down the road is we'll have seed orchards where we can collect seed to grow resistant seedlings. That's a long way down. So the first you have to see how the disease resistant is durable, the durability of resistance in the field. And then you have to see what the heritability is of it. So just because a tree is resistant, does it pass its resistance on to its offspring there? So that's another round of maybe 5 years to grow it out and another round of testing of these things before we can start saying, yeah, these are resistant trees. And then just the developing the seed orchards is going to be a complicated task because we have so many taxa of ʻŌhiʻa and we want to grow ones in the appropriate zone. So you might have a wet zone in Cana and a wet zone glaberrima, and then a high elevation polymorph on a wet and a dry zone and different things like that. And that's just thinking Big Island, you know. I mean, what do we do? We're still learning, for example, for the Oahu or the Kauai endemic species, even, you know, how much resistance there is in those populations. The Akaka Foundation for Tropical Forests is helping fund this program, and on their website, they have a nice set of information on the disease resistance program. Another newer program on ROD is looking at integrating various pests, especially to the lowland ʻŌhiʻa. The Flint Hughes that the Forest Service has 250 plots out on Hawaii Island looking at the progress of ROD. So these are all plots where they are ʻŌhiʻa forest. They found some ROD. One of his findings, which is sad but unsurprising, is he saw no ʻŌhiʻa regeneration below about 3,000 feet. So below 1,000 meters, there are no ʻŌhiʻa seedlings coming in. And anybody who's been in the forest knows why. It's all taken up by strawberry guava and clidemia and meiconia and everything else. Whatever ʻŌhiʻa seedlings are, they can't germinate and grow. We know there's the seed rain there because if you have substrate like a rotting log or a rock wall or something like that, you see seedlings growing up on it, even in these low elevation areas. But in the forest, you're not seeing that because of the weeds. So this is a program where the forest ecologists are working with Tracy Johnson, who is the entomologist who developed the Tetrococcus biocontrol for strawberry guava, are looking at, well, how can we maybe get some regeneration there by excluding pigs or not excluding pigs, and then cutting the strawberry guava and bringing in the biocontrol to control the regrowth of the strawberry guava. So if you do both animal control and weed control, can you regenerate these forests? And that's integrating two of the main threats to the ʻŌhiʻa forest on there. And it's a study that's just getting started. A a different program and a community program of restoring a forest is down here in Lower Puna. This is actually a community managing some land and in the State Forest Reserve. The State Forest Reserve, the Komohana Forest Reserve, is really badly hit by rod. It is only a few miles away from the first places that we saw rod, so one of the very initial things. So they've had rod for a decade there, and you can see how open the canopy is there. A lot of the ʻŌhiʻa canopy have died. This is a community group that started saying, what can they do about it? And they've been working in some of the forest to remove the weeds, cut the strawberry guava, pull out the clidemia, and then plant other forestry species. So you see okay, I'm going to call it a tetraplasandra. Okay, I know it's polycious now, but ʻohemauka, there you see one of the ʻohemauka, which is one of the trees that always was part of the canopy, but now is going to become an important part of the canopy. And so you've got Wickstromia, Akea, Mamaki, of course, and a number of other, the wet copico, a number of the other wet forest understory species that are now gonna, in this future forest, gonna form the canopy of that. So it is not going to restore it to the original conditions, although this would be a great place once we start getting disease-resistant ʻŌhiʻa to plant it out. It's not going to restore it to the original conditions, but it is going to be a native forest. And the cool thing about that is it's a community-led project. There's the website, HawaiiEnvironmentalRestoration.org. They do have some funding from the Rare Plant Program to fence it. Now they've still had pigs in the area, even though they've been doing a lot of native outplanting. The little plant in the bottom right corner is an endemic Sertandra nanavaleensis. So Nanavale is the subdivision just up the road from them. And this Sertandra only lives in a very limited area of Lower Puna. So some of the rare plant money is going in there to protect that forest. This is the year of the community forest, according to DLNR, and this is one of the efforts of a local community to take care of their forests. What do we do? Keep planting ʻŌhiʻa. One of our really valuable research insights has been that seedlings don't seem to take up the pathogen through the soil. So it's not something like nematodes, that if you have nematodes in your soil and you plant a susceptible plant, it's going to get infected. The pathogen doesn't seem to take up through the roots unless the roots are injured. So if you fence and you can plant ʻŌhiʻa trees, you can keep planting ʻŌhiʻa. That research was done by Stephanie Elnick, who was with the USGS and now is with the U.S. Forest Service on it. The other thing I do want to mention for those of you not on Hawaii Island is you can plant ʻŌhiʻa all the way down to sea level. The reason you don't see ʻŌhiʻa at sea level on Oahu or Kauai or Maui is because it was all eliminated by people, not because it doesn't grow there. Here on Hawaii Island, we know because we see ʻŌhiʻa on the Puna side all the way down to sea level. So keep planting ʻŌhiʻa. We'd love to see more ʻŌhiʻa in the built environment. And protect your forests. It's easier said than done. Fencing is expensive. You do need fencing that'll keep pigs out, like the hog wire on the top. A landowner in Volcano did the whole chain link fence around their place, but that's really protecting their ʻŌhiʻa. Another landowner, a neighbor there, just has the electric wire around. Cheap, but you have to live there and you have to check it constantly. But she's found that she's been able to keep pigs out just by having an electric wire fence around it. So I wanted to throw out a few new things, a few current developments for people about what's going on abroad. And I do want to be hopeful about it with the different tools we're getting for managing different projects, different problems, and also to plug our video that I hope people will see and hope that will engender a lot of conversations. I know DLNR has more money for building and maintaining fences. And it's, of course, it has to be a continuing discussion with the community, where those are appropriate, where those are useful. There's my contact information along with my assistant, Charlotte Godfrey Romo. And we are on the web, we're on Facebook and on Instagram as ʻŌhiʻa Life. So thank you very much for listening. And I'll stop sharing and take questions.
Thank you, JB. So a few questions that came up. Is there any, or can you talk to any research that's been done with rod and pahutakaua from New Zealand? We know that they're ancestral trees.
Yeah, I'm just hesitating because I know they did test the seed stock. They got some seeds. So the New Zealand that actually funded us some on this. And I believe that it was not susceptible. So I think they were not successful in inoculating it with the pathogen. So they're testing some other ones. I would, if the person inquiring would send me an email, I would look up the result on that. It's something I was trying to remember was it. But they are testing, and they're testing some other New Zealand Metrosideros species. For those of you who don't know, there are 11 or 12 Metrosideros species in Aotearoa, New Zealand. And they are definitely iconic trees there as well. And they are definitely very concerned about it. New Zealand, however, does not do things like import untreated wood, which would bring the disease around. We need better biosecurity. I won't point the finger at anybody for bringing the rod fungi in because we didn't know what it was. But for a lot of things, we need to have better biosecurity than we do.
And to how rod came into the States and to Hawaii, what I've heard that it was probably coming in on some other plant that was asymptomatic. Are there any other plants that are susceptible to the ceratocystis rod species?
Yeah, so the two species that are here aren't found anywhere else in the world. So how did that happen? They snuck in under the radar, just nobody knew because they're pathogens all over. And thus they call it a problem. We don't know what they are. That's probably not as likely as they mutated once they got here. They got here on something else, and then they mutated to something that could attack ʻŌhiʻa. So there's a ceratocystis that hits taro that is somewhat similar to the Julio ʻŌhiʻa. That could have been the ancestor to that. The one that attacks the leucohea, the more virulent one, there's a somewhat related one that is on Syngonium, which is ornamental aroid, and it continues to get that. There is a ceratosis disease that's been here for a long time on sweet potatoes. It's not that closely related to either of the ones we have. So we do have records of ceratocystis, different species coming in on horticultural plants, but we don't know what was the ancestor of these two species that are causing rod. And like I say, that would have been hard to intercept because we didn't know what was going to mutate and jump, as opposed to some of our other pests and certainly our weeds that we jolly well know that they're problems, but we still don't intercept them.
Thank you. And then the last question was, has there been any studies about how function has changed in these highly impacted rod forests? Have there been testing done on watershed function and retention?
Not that I'm aware of on the watershed function retention. The one impact that's been documented, it was documented actually fairly early on, is some of the forest birds were starting to recolonize the lower Puna ohia forests. You were getting amakihi coming down, and it looks like they're adapting to the malaria and being able to reproduce in these lower elevation forests. And then with the loss of ohia, they've lost their habitat. So that put a stop to something that was very hopeful, is that some of the birds that were more tolerant to the avian malaria were able to survive and start reestablishing populations. And that was reversed with this. Watershed, no, it would be really difficult to document it, although you can use principles to think about what's going on, that ohia is not very fast growing. I wouldn't say it's slow growing, but it's not very fast growing. It doesn't use that much water. If it's replaced by albizia, which is much faster growing, uses much more water, it would decrease the watershed recharge on that.
Well, thank you so much. I have no more questions for you and really appreciate you taking the time and updating us on the latest. I have put into the chat upcoming webinars for the rest of Hawaii Invasive Species Awareness Month. So please go to the website, and there's a lot of different topics, both terrestrial and aquatic and marine. So please check it out and learn all about what's at risk and what we're trying to do to protect it. So thank you everyone for joining.
Okay,
Please
thanks for
share
joining.
the recording. Thank you, JB, and aloha.
Okay, aloha.